Hello, fellow viewers. Have you ever wondered what it's like to be drifting in space with zero gravity? Oh, you've never experienced it, right? Well, I too have never experienced it, but I can assure you that today you will get the experience of a lifetime. Because what me and my crew are about to do is to explain each of the processes of the mission called Man on the Moon. So sit back, relax, and grab some snacks because this is gonna be a whole long, exciting ride. Before we further show and explain about the mission, my crew are going to briefly identify some valuable terms so that you don't have to open a dictionary mid-lane. First thing to start off is gravity. Gravity is the magic that the Earth gives for living things. It can both be magic and stupid at the same time. How old are you when you realize that gravity is trying to pull your pants down? What an inconsiderate prick am I, right? Now let's get straight to the point, shall we? We don't want to waste time trying to make a meme over here. The word gravity was dated back during the Isaac Newton era. Isaac Newton, however, was just minding his own business until an apple bonked his head and made him unconscious. The only thing that is wrong with this whole scenario is that it's fake. Again, how old are you when you realize the story is fake? Let me guess today, year old. Lucky you, you're not the only one, for I was fooled with this story. Screw you to whoever told me about the lie. The story, however, is just created in the purpose of serving a kid's happiness. Anyway, back to our point. As said by NASA, gravity is the force where it pulls an object with mass toward its center. As a reminder, this video is under jurisdiction of parental advisory content. So if you have a child watching this, please pause the video, like it, and hit the sub button and move on to watch other contents. Gravity is so important that without it, the universe would cease to exist. The gravity of the sun is so humongous that it enables every object mass within the solar system to keep orbiting, and by that creates life on Earth, and also creates heat every 12 hours or so. Hear me out. There's a myth which is known to almost everyone on Earth. The myth states that there's no gravity in space. While many people, perhaps even you too, think that there's no gravity in space, however, that is not very true. For example, black holes are known to suck things out of existence, which you've probably known from movies. In accordance with science, it's true because black holes pack so much mass that they're able to use their force of gravity to even keep light from escaping. Another thing to relate is why astronauts in floats in space. If you're an introvert, then you've probably seen that video of Usain Bolt, the fastest runner on Earth, ran in a space simulation, and it looks like his speed inside the simulation is lower than his speed on a racetrack. To keep you from wondering what that is, because they're in a state of motion called free fall, like the experiment done on the moon where a hammer and a feather drop at the same time. Since there is no air resistance in space, therefore astronauts only experience small amount of gravity, or scientifically saying microgravity. So what is freefall and microgravity? By the given definition from NASA, microgravity is gravity but in a small portion. Freefall, on the other hand, means the act of falling that is basically subjected to the Earth's gravitational pull.
We all know the man behind the three law of motions, and Isaac Newton came up with all of them in order to better our life, and is the foundations of most certain technology, as believed by the man himself. He stated that every particle attracts every other particle in the universe with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their center. What does this whole law even mean? Luckily, I'm here to sum it up into one sentence. In short term, the law itself means that the force between two masses is equal to the gravitational constant big G. time the mass of the first object time the mass of the second object divided by the distance between the two objects squared. You still don't get it, do you? Alright, I will make it easier for you. So here's the formula of force, and now let's compare the phrase to the formula. Uh, Briefly identify the phrase with the formula. See, it's not that hard. The distance between a 40 kilogram person and a 30 kilogram person in 2 meters. What is the magnitude of the gravitational force each exerts on the other? So the universal constant 6.67 times 10 negative 11 newtons, and yeah, kilogram square. So magnitudes of gravitational force. This is the solutions of the magnitudes of gravitational force.
Okay, so for most kids born during the 21st century, I expect y'all to be familiar with the mission carried out by the government, sending two men towards spacecraft and the intentions of being the first to step foot on the moon. So if you ever heard or known about this, then this explanation is okay. Since the process is very complicated, so we'll try to put it in easier words so that you, the viewers, won't have to worry about asking others for help in explaining, whereas you instead can explain to others and prove your knowledge to both your teacher and your parents. Okay, let's put it this way. Imagine you're on a spaceship wearing your suit, ready to take off at the speed of light, but it took you about 3 hours to launch into space. Why is it so long? Well, you don't blame the guy who refused to ship fuel, but instead blame it on the Earth's gravity. Since the Earth's mass is heavier than the Moon itself, making the Earth have a greater gravitational pull on the spaceship, that is also the reason why launching your spaceship from the Earth requires more time and more fuel than launching from the Moon, which you probably would have finished my sentence in the end. You guessed it right, it's gravity. In order, if you've known about the mission itself, my crew are going to bring up the gravitational formula in order to prove my above statement. Launching your spaceship from the Earth requires more time and more fuel than launching from the Moon. So, in order to substitute the values in the formula, we need to know the distance between the Moon and the Earth and the masses of both planets. So, before we continue, we would like to tell you that the pictures, models, or even measurements are not to be scaled to precision. On the behalf of the information given by Armstrong and his crews during his trip to the moon, the distance between the moon and the Earth is approximately 384,300 kilometers. On the other hand, the mass of the moon is estimated to be 7.34 times 10 to the power of 23 kilogram, and the Earth is determined to be 5.97 times 10 to the power of 29 kilogram. Now, if we were to substitute those values inside the formula, we will get a value that is in accordance to the difference between the gravitational force and the distance. To better explain this, we will demonstrate a graph. So you can see from explanations to examples to even graphs, this does however prove that the velocity of the spaceship traveling from the Earth had a huge change than the velocity of the spaceship that travels from the Moon towards the Earth. Now, to sum up everything me and my crew explained so far, first of all, gravity is sus. Second, the story of an apple dropping on you head is fake. Third, the Earth would disintegrate without gravity. Fourth, there is gravity everywhere, even in space. Fifth, astronauts float because of the state called free fall. Sixth, Isaac Newton is not a scientist but a god for being responsible for up to 90% of humanity's technology or invention. Eight, seventh, my bad. Seventh, the moon landing was America's greatest success. Eighth, the statement launching your spaceship from the Earth requires more time and more fuel than launching from the moon is true when using or substituting inside the gravitational formula. Now, if you've had any questions regarding the topic, please put them down in the comment and we'll attempt to answer it. After all, this video is not made for educational purposes, but instead it's a science project. So any related information contained in this video are not to be reused in any sort of way. And before you end the video, I want you to yeet that like button, all right? Smash that subscribe button and make sure you hit that bell icon for more related information. It would mean a lot to me and my crew. Now, speaking of my crew, shout out to both of my crew, Mouykeav and Nina, who very much explained this whole thing, especially for you, because you deserve to know better. And make sure to go check them out. Links are in the description below. Anyway, much appreciation for spending your valuable time and watching this video. And finally, have a great day.